guys, we're going to talk a little bit about geometric probability. And so we talked about probability earlier this year, right? So quick review of probability, it's desired outcomes over total possible outcomes, right? But what we didn't really do a lot of while we were talking about probability was how do we do that in terms of geometry stuff? And so it's basically going to come down to two scenarios we look at today. We're going to look at probability in terms of length, and we're going to look at probability in terms of area. So basically what we're going to do is just replace the word outcome in that probability formula with the word length or the word area. So for this first one here, we're going to look at the probability that a point is on a given segment, given that we know it's on a certain segment. And this is going to all have to do with length. Basically, we're going to say, what's the desired length over the total possible length we have to work with here? So I'm going to call a point A and put it at the end of a segment. And then we're going to go down from there, and I'm going to put 12 little hash marks on the segment. So I might have to make it a little longer. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Wow, I made that work out pretty decent. That usually doesn't happen. All right, so there's B. And so we know our total length here that we have to work with is 12. And just to make it even easier, I'm actually going to label all these across the top so we can see where they are. And then I'm going to put a couple other random points on here. So let's say I have a point C right here at 2. Let's put a point D right here at 5. And let's put a point E right there at 9. And let's see if we can find some probabilities based on that information. So we know that the point is on AB, right? That was given. So we only have this to pick from. But what I want to know now is, knowing that it's on AB, what's the probability that it's on AC? So this really comes down to thinking about lengths. What's the total possible length I have to pick from here? Right? 12. And so remember, the way probability works, it's what we want over total possible outcomes. Total possible length we have to pick from is 12, right? So that means what we want would go on the top. So what's the length that we're looking for here? 2. So that means, do you notice AC, that's 2 units long, right? And so we have 2 out of the 12 to pick from. And we know from probability from before, we shouldn't leave our answer like this, right? What does that simplify to? 1/6. So we can make it 1/6. Or remember, with probability, you're actually always allowed to make it a decimal or a percentage as well. So if you wanted to, you could change that to 16.6 repeating percent, and that would be fine. Right, so is everyone okay with how we're getting this? All right, let's try another one just to make sure we're all good. And I'm going to switch things up a little bit on this one, and I'm not going to start at the very end. So what if I said CD? So you notice this one doesn't start at the end, but it's still the same idea. We still want, what's the length we have over the total possible length we have to pick from? Doug, what do you think?
4 over 12?
4 over 12. You guys agree? See a lot of yeses. It's not 4 over 12, actually.
Is it 3 over 12?
3 over 12. Now, when we're dealing with length, let's think about it this way. And this was a big problem last period had as well. So from C to D, how far did I move? Think of these as if they're inches. And so this doesn't actually count as a point, does it? Like, you have to go from here to there is 1 unit, right? And so that's 1 unit, 2 units, 3 units to get from there. Is everyone okay with like how we're measuring that? So think of it kind of like a ruler. If you set a ruler here to measure from here to here, this isn't 1, this would be 0, right? So 1, 2, 3. Or another way you could do it is subtract the numbers, right? 5 minus 2 is 3 units we went. So it's 3 over 12, which what does that simplify to? 1/4, good. Or if you really want a percentage, you could call that 25%, right? Is everyone all right with how we're getting that now? I thought we better do one like that, because that's an easy thing to like, you just want to count all the dots, right? And so you have to think length though. The first one doesn't count. We go from there to the next one, that's our first one, right? How about one more? What if I say C to B? so from C to B, what's our probability here? What do you think?
10, 12.
10 12s, good. From C to D, we're going 2 to 12, or C to B, sorry. We're going 2 to 12, which is 10 units. Whole length is 12 units, so we got 10 over 12, which we should simplify to 5 6, right? All right, trick question. I'm not gonna write this one down, but what if I said, what's the probability that it's on AB? 100%, or 1, if you wanted to put it as a fraction, right? And I know 1 technically isn't a fraction, but it would be 12 over 12, right, which would simplify to 1. All right, so is everyone okay with this idea? So really what we did is we took the desired length over the total possible length. That's kind of what we're doing here, right, to find these probabilities. All right, so I want to change up a little bit now, and let's talk a little bit about area. So for area, we want, what is the probability that a point chosen at random is in the rectangle in the shaded region? Now, I'm going to give you some context for a problem like this, like why would we care about something like this? So one case where you would have to do something like this is like a search and rescue kind of deal. So like, for example, if you have, like, let's say you're in the Coast Guard and you got a distress call. Well, there's a certain area that distress call could be in. Because you're going to get a call, you're going to be able to get an idea of where the signal is, but you're not going to get exact location, and the top of the ocean is not perfectly still. So if somebody like goes overboard, they're not going to stay in the same spot. There's currents that's going to move them around. And so you're going to have to search an entire area, not like a specific spot. Unless they have like some sort of like location device on them, you're not going to know exactly where they are. So if you think about when you go out with a helicopter and hover over the water, what's the shape of the area you could scan from a helicopter? A circle. Basically, you'd see in a circle around the helicopter, wouldn't you? So you'd cover a circular spot of most likely a rectangular area, or maybe a circular area of a bigger circle that you know that they're in. So just to give this some context for like why you would want to do something like this. So let's say you're going out in a helicopter on like a search and rescue mission, and you got a distress signal, and you know they're in like this certain rectangular area, and in your helicopter you can cover a certain circular portion of this. So there's going to be some bigger numbers on this one because, you know, like if we're covering a whole area in the ocean, it's probably going to be a decent amount. And so let's say you can cover a radius of 80 meters from the helicopter. So this is like my shaded area. And if you can't see that, I'm going to say it out loud because I had to draw it kind of small in here. It's 80 meters. All right, so let's say this part right here is 600 meters by, let's go with 1,000 meters this way. All right, so this is the whole area we need to search. This is the area we can search in one spot. So if that's the case, kind of the question becomes, what's the probability you find them in the first spot that you go to? That's kind of what this would be, right? And so that's actually the same problem as that. What's the probability that a point chosen at random in the rectangle is in the shaded region? So let's see if we could do this. We're going to need to know the area of this circular area we can search, right? And we're going to need to know the entire area that we're looking at. So how do I find the entire area that we're looking at? Basically a rectangle, right? 1,000 times 600, right? And so this is going to be kind of a big number. So I'm just going to say area of rectangle is 1,000 times 600. Length times width is how we find the area of a rectangle, right? So 1,000 times 600 is 6. All right, so just like putting all the zeros in there that need to be in there, this would be 600,000 square meters. So that's how much area we need to search, or that's our search area, I guess, and we can search this much at once. Now this we learned yesterday, right? How do we find the area of a circle? Pi times radius squared, and our radius here is 80 meters, right? So if I want the area of the circle, we're going to do pi times 80 squared, right? Which this I can't do in my head. This is going to be a fairly big thing, so let's figure out what this is. So if we do pi times 80 squared, 20,106.19 or so. Alright, now remember though, the question wasn't just like find the areas, the question was find the probability. What do I do with these things now to make it a probability? Let somebody else, I feel like you answer a lot of questions. So what do I do with this to make it a probability?
Put the area of the circle over the area of the rectangle.
Put the area of the circle over the area of the rectangle, exactly, because basically, isn't probability always desired outcome over total possible outcomes? Let's just replace the word outcome with area. Desired area over total possible area. And so the desired area is 20,106.19, total possible area is 600,000. Now I kind of did one on purpose where the numbers don't work out nice. There's really no hope of simplifying this fraction, right? Because the top's technically an irrational number. It doesn't have a pi in it, it goes on forever, really. So the best option here would probably be get this as a percentage. And so I'm just gonna go ahead and divide these two numbers, which gives me like 0.0335. Or in other words, if I wanna make it a percentage, I move the decimal point 2 places, right? So this is about a 3.35% chance that you find them in that first spot that you go to. So not a great chance, but that's okay. I mean, you're gonna like take the helicopter and drive around until you do find them, right? Hopefully. Unless you're a really bad Coast Guard person, in which case you just be like, didn't find them the first time. They'll be okay. They can swim, right? So hopefully you don't do that and you actually try to find them for a while. So is everyone okay with kind of how this works though? Like the idea of how we're finding these probabilities? So take the area you want over the total possible area, or if we're in length, take the length you want over the total possible length. And that's how we're gonna do probability from a geometric standpoint. So any questions on this?